So let's talk about how to divide complex numbers. Excuse me. So I want to, let's do this example. Let's divide 2 minus 7i by 1 plus I. So this is similar to, if you'll remember with square roots, if I had something like the square root of 3 divided by the square root of 7, we would say you don't want that, because one of the rules is you can't have a square root in the denominator. So how did we get rid of the square root in the denominator? We multiplied by the big one. And in this case, the big one was the square root of 7 over the square root of 7. So with division of complex numbers, we have the same thing happening. We don't want to have an I in the denominator. So I'm going to have to find a way, find something that I can multiply this by, the big one, that would get rid of an I in the denominator. So I have to think about what could I multiply this bottom by that would get rid of I? Well, we just talked about that. We said that to get rid of I, you multiply by a conjugate. So the conjugate of 1 plus I would be 1 subtract I. Notice the 1 and the I stay the same. The only thing I do is I change the sign in between. So since I did that in the denominator, I'm going to do it in the numerator. So I've multiplied by the conjugate here. So let's multiply this out and see what happens. On the top, I get 2 minus 2i minus 7i plus 7i squared. On the bottom, I have 1 minus I plus I minus I squared. Well, on the bottom, this happened on the denominator. This happened exactly what I wanted to happen. I wanted the i's to cancel out, and they did. The two middle terms canceled because these were same numbers, opposite signs. And the negative I squared turns to negative 1, but because it's opposite of negative 1, this whole thing just turns into a plus 1. So on the bottom now, in the denominator, I have a 2. On the top, the I squared also turns to negative 1, so this whole thing turns to minus 7. So I have 2 minus 7, which is negative 5, and negative 2i and negative 7i is negative 9i. So what I wanted to happen was to get rid of the imaginary numbers in the denominator, and that happened because I multiplied by the conjugates. Let's do another one. By the way, in Delta Math, I think you'll be able to write it like that, but if not, they may divide it up so that it looks like this. You'll have to kind of play around with that, maybe guess on the very first one so you can see how they want the answer written. These mean the same thing. All right, here's another one. Let's do 3 plus 11i over negative 1 minus 2i. A real tempting thing to do would be to want to just cancel out these i's, but you can't do that because you have plus or minus here. So I'm going to multiply by the big one, and it's going to be the conjugate of the denominator. So I'm going to have negative 1 and 2i, but instead of minus 2i, I'm going to put plus 2i. Notice the negative 1 didn't change, the 2i didn't change. The only thing that changed was the sign in the middle. So let's multiply this out. On the top, I'm going to double distribute. So I get negative 3. 3 times 2i is 6i. 11i times negative 1 is negative 11i. And 11i times 2i is plus 22i squared. In the denominator, negative 1 times negative 1 is 1, minus 2i, plus 2i. Good, these are just opposites. They're going to cancel. That's what I wanted to happen. And then minus 4i squared. And I squared turns into negative 1. So this whole thing turns to minus 22. I squared is negative 1, so this turns to plus 4. So in the numerator, I have negative 3 and negative 22. That's negative 25 minus 5i over 5. Now, this one, I know I told you at the beginning, you can't just cancel out the i's because of this plus or minus, but look what happens here. Do you see how everything is divisible by 5? So what I could do is factor a 5 out of the top and be left with negative 5 minus I over 5. And now, since these are both factors, they will cancel. So my answer would be negative 5 subtract I.